Power outage again. What if I told you this potato could help light up your room? Well, maybe just a small lamp. Today, we're making a simple potato battery perfect for your next science investigatory project. Hi, I'm Teacher Jay from SIP Made Easy. With power interruptions becoming more common, learning about low-cost emergency power ideas is not only useful, but it's also a fantastic topic for your school science project. Our aim today is to test whether a potato can generate electricity and figure out how. Many we need to power a small LED or a calculator. Our hypothesis is that a single potato will produce a small voltage, but by connecting more potatoes in a series, we can increase that voltage enough to power our devices. So, what do you need? A few potatoes of the same size, some copper strips or pennies, zinc or galvanized nails, alligator clip wires, a multimeter, and a small LED or a low-power calculator. You'll also want a knife and a cutting board. A quick safety reminder, always be careful with sharp tools. Avoid letting your connections touch or short out, and never ever connect this project to your home's main power supply. Let's start building. First, prepare your electrodes. Use a clean copper strip for the positive electrode and a zinc nail for the negative one. Now, push the copper and zinc into the potato, about 2 to 3 centimeters apart. Make sure they don't touch inside. Next, let's measure our single potato cell. Connect your multimeter leads to the copper and zinc using the alligator clips. Set the multimeter to DC voltage and write down the reading. To get more power, we need to connect our potatoes in series. This means you connect the zinc nail of one potato to the copper strip of the next potato using a wire. You'll be left with a free copper end on the first potato and a free zinc end on the last one. Now, measure the total voltage across the entire chain. Then, switch your multimeter to the milliamp setting to measure the current. You can do this by briefly connecting your LED or calculator through the meter. Time for the real test. Try lighting up the LED. Remember, polarity matters. The longer leg of the LED is positive and should connect to the copper side. If your LED is dim or doesn't light up, add more potatoes to your chain or double-check all your connections. Make sure to repeat these measurements for 1, 2, and 3 potatoes, and keep all your data in a neat table. Speaking of data, you'll want to record the voltage and current for each setup. Don't forget to take photos of your experiment for your SIP report. Also, note any changes you see over time. A potato battery's power can drop as the electrodes start to corrode. So how does this work? The potato isn't the power source itself. It acts as an electrolyte, like the acid in a car battery. The zinc loses electrons, and the copper gains them. This flow of electrons between the two metals is what creates the electrical voltage. When you connect more potatoes in a series, the voltages add up. While a potato battery isn't going to replace our power grid, this project is a great way to demonstrate how simple electrochemistry can generate a small amount of emergency power. It's perfect for showing how to power tiny devices or for creating educational kits about electricity. And that's the potato battery SIP. It's simple, cheap, and a perfect project for school. You can even try variations with different fruits, like lemons, and compare the results. If you'd like, I can upload a downloadable lab template for you to use. Thanks for watching. If you enjoyed this, please give this video a like, subscribe to the channel, and comment below what fruit you want me to test next. See you in the next video.